Hello, good morning and welcome once again to another video of binomial distribution. Here I will be discussing another problem related to binomial distribution. In this, the question here is, if the probability of having a male and female child is 50%, then what is the probability that a family's fourth child is their first son, a family's fifth child is their second daughter, a family's 10th child is their fifth or sixth son. So these are the three problems which are to be solved, and the probability of having a male or female child is 50%. That means male or female. I think the correct way to write it is male or female child is 50%. So these are the questions need to be answered. First, I'm going to show you how I have manually you can do that by using a binomial distribution. So I'm interested in calculating probability of fourth child is first son. I'm doing part A. So it can only happen if both of these things take place. That means there is no son in first three trials times the last trial results in a son. That means in the first three babies are not a son and the last baby is a son. That's only it can be done. So what I'm interested in, if you can relate this text to the notation which I've written down under, probability that capital X is equal to 0 for n is equal to 3. That means in first three trials, in capital X is a random variable of getting a male or female child. So x is 0. So that means probability of success or getting a son is 0. So x is a random variable which is representing here son. Like means if the child is a son, a male child. And then probability, the last trial results in a son. That means last random variable results in one success. That means for n is equal to 1. That means one trial results in one success. And out of first three trials there is no success at all, and since both of them should happen, then only I'll get my result here. So that's why I'm multiplying them. So it is a case of and this happens, then only I'm going to get my result. So you know the binomial distribution function. I'll just drag it here. This is right here, binomial distribution function. Px is equal to x, ncx, px, qn minus x. So same way values are supplied in both the cases, and I get the output, which is 0.625. So that is a manual solution. You can do it manually. And how I'm going to do it by using an Excel, I'm going to use binom dist, the same function which I used earlier. Now I'm interested in numbers. So how many successes I'm interested in? I'm interested in 0 successes. 0 successes in 3 trials where the probability of success is 0.5 given in the question, and I'm also interested in exact match times, again, binom dist function, binom dist. Now I'm interested in, look at this particular part here, one success out of one trial with a probability of 0.5 once again, and again I want an exact match. So you can see the function. This function is exact replica of this manual calculation right here. And if I hit return, I get my answer 0.0625. And if I convert it into a percentage, that means there is a 6.25% chance that fourth child is the first son. Now I'm going to calculate the second part where it says a family's fifth child is second daughter. So fifth child is second daughter. Now capital X will become the capital X, which is representing the random variable. You can think random variable as that it is the random variable which is representing the birth of a daughter. So I'm interested in knowing fifth child is their second daughter. Now you can relate this particular case right here. Now it can only happen, that means if in first 4 childs there is one daughter and the last one is also a daughter, then only the fifth child is going to be a daughter. So if I just amend this particular thing, so now I'm interested in fifth child is second daughter. So what is going to happen? Now I need one daughter in first 4 trials, because fifth child I'm talking about, first 4 childs, and last trial results in a daughter. So I need these two things, and then only my question can be solved, can be answered. So probability of x is equal to 1 in first 4 trials, and probability that x is equal to 1 in last trial. So now not write this whole stuff once again. Rather, I'll just straight away do a binomial distribution function. So binom dist. So I'm looking for one success in first 4 trials with this probability, and I want an exact match. So I'll type 0, as I told you earlier, times one success. Again, I'm going to use my binom dist function. Binom dist, one success, one trial with this particular probability of success, and again I need an exact match. So I'll type 0, the Excel code, and that gives me answer 0.125. This is the probability of getting fifth child as second order, and I can convert it into a percentage. Now the last particular case thinks 10th child is 5th or 6th son. 5th or 6th son. Now in this case I am going to consider two cases. One is how can I get the probability of 10th child as a 5th son. Then I'll calculate probability that a child is 6th son, and then I'm going to add them. So let's put up same way again. I hope now you can understand the things a little quick. Binomial distribution. Now I'm just bothered about now 5th. That means 10th child is 5th son. I'm not thinking about the 6th right now. So 10th child can only be 5th son if in first 4 childs there is how many 10th child. So in first 9 childs there are already 4 sons, then the last one is a son. So I'm interested in 4 successes in first 9 trials with this probability here, and I want to see an exact match, times again binom dist. You can also copy the formula if you want. One success in last trial, and with this particular probability of success, and again I want a false match. That means an exact match. Plus, so this whole function gives you the probability that 10th child is a 5th son. Now I'm calculating probability of 10th child is a 6th son. So I'm going to use my binom dist function once again. Now in how many sons I need in first 9 trials? 5. 5 successes I'm looking forward to in 9 trials with this probability here, and an exact match once again, times binom dist. And again I'm interested in like one success in 1 trial with this probability right here, and the exact match 0. So if you look into the formula, I have broken it into 2 parts. This particular part here explains the probability of getting a 10th child as 5th son. This particular part is probability of getting 10th child as 6th son. So probability of getting 5th child plus probability of getting a 6th child as a son will give you the combined probability of whether it's a 5th or 6th son. And I hit return, that's it. And I can convert it into percentage. So there is a 25.61% chance that 10th child is 5th or 6th son. So thank you very much. This concludes the discussion on binomial distribution. You can post your comments, and please post your comments about any other questions if you want to hear from me. Thank you very much.